All right, hello and welcome to the fifth session for Foo-Bar Java review session. My name is N. Rizvi. I will be your host for this evening. Just wanted to make sure that we have some people in the audience before we get started. And if we have someone in the audience, if you could please confirm that my audio is on correct, and then you can actually see me, you can see the screen, so that we know that the setup is done properly. I always like to do this beforehand, just so we can make sure that the stream starts up and is able to do things properly. Everything looks perfect. Thank you, coffee pizza. That's a great combination, by the way. And then setup is great. All right, thank you very much. Power. In the past, I think if we waited a few extra minutes, that allows more people to show up. So why don't we wait until 7:03 before we actually get started? If you have any question beforehand, please let me know, and then we can do this a very short, quick question answer session if we need to. If not, I hope the semester is going great. I know we're near the very end. We have about a week left. For students at University of Calgary, Computer Science 233 and 219, we have the projects which are due next week. I'm really looking forward to some of the projects that are coming up. I've seen some of the progresses so far, and they look amazing. So looking forward to the final results there. All right, just waiting one more minute before we get started. It appears we have no questions, at least for the very beginning, which I'll take as a good sign. If people are handling the content well, going great, the assignments, the coding challenges so far, the practices, that's a good sign. Project is amazing because you have the best TA. Well, then you might not be in one of my tutorials. All right, so let's get started. It is 7:03. It does look like we have a few people. Blue Barn, welcome. And welcome to everyone else here. Once again, my name is N. Rizvi. I will be your host for this evening. The agenda for today, once again, the disclaimers, which I have to do at the very beginning of every session. And as well, today's topic, as I mentioned earlier, would be recursion. By earlier, I mean on D2L for students. So once again, these online sessions are not part of my TA duties, even though I'm a graduate student at the University of Calgary, currently a TA for Computer Science 233. These sessions do cover Java and object-oriented programming concepts review, and they are tailored towards students in CPSC 219 and 233, offered at the University of Calgary, but this is like an extra help I'm offering. It's independent, not part of my TA duties. If you do enjoy these sessions and you find them useful, maybe let the department know that you find these kind of sessions interesting and useful, because we may not have to stay with the former type of tutorials which are in class, which has its own merits and its own usability. I'm not saying this is better than in-class tutorials. I'm just saying these are different, and each has its own strength. About the chat, so feel free to ask questions and have discussions in chat. If you know if you can answer other people's question, feel free to do so. And then once again, when we finish this tutorial, the video will be posted tonight on the YouTube channel, in case you need to come back. So without further ado, let's get started. I had 4 sample problems to work with recursion, and these 4 you should be seeing on your screen. I'm gonna just move them a little bit to the side, so that I know at least part of my screen is being covered by the chat, so I just want to make sure everyone can see the whole screen. And then we'll be covering these four problems, computing a factorial, reversing an array list, and then finding palindromes and the Fibonacci numbers. Hello, Indolency. And before we actually get started with these problems, you may notice that these particular problems are something that you can actually figure out how to do using a while loop or a for loop. So you don't necessarily need recursion to solve these problems. But the idea that we're trying to enforce here is that recursion is a way of solving certain types of problems. Those problems are a lot more difficult when you try to solve them using a while loop or a for loop or another measure. So that's where recursion comes in handy. The reason we use these simple problems is so that the actual solution is not that very complicated. So you can actually come up with the solution to get started for your very first experience with recursion. And if you need to, you can actually verify the solution yourself using a different solution, meaning, like, let's say actually computing this result. If you can come up with the actual result using a for loop, that way you can verify your solution for the recursive solution, so that they give the same response. And yeah, so we work with toy problems at the very beginning, but then when we get to the more complex problems, if you already know how to think about recursion, it'll be a lot more easier. So this is just getting started. I realize you can do these problems with using for loops and while loops, but we're doing recursion to get a handle on how to actually use recursion for solving problems. Hopefully I made that clear. So let's get started. As always, we'll start off with a new project. Session 5. And we'll just create a single class here called recursion. And each solution is going to be a method of its own, so that it's easy to maintain. So we're not working with multiple classes. So the first problem here, I'm going to copy this, put this as a comment here so we know what we're doing. And hopefully everyone understands what I mean by n exclamation mark. It's not that I'm excited about the character n. It's actually a mathematical symbol in this case. So we're computing the product from 1 all the way up to n. So 1 multiplied by 2, by 3, by 4, all the way up to n. It's not just n. Okay, so I shouldn't have done that, sorry. So let's get started. So yeah, public and then factorial. So we get an integer n. And the way we recognize recursive problems is that the method is supposed to call itself. The factorial method is going to call itself in order to come up with a solution. But I'm expecting that you have at least you're at least somewhat familiar with recursion, so I won't go into the very beginning of recursion. But this is more about actually using recursion. One thing we want to do is there are 3 steps to recursion. The first step is the base case. Base case means when does the recursive process ends? When is the case that we don't call the method anymore? We just stop, and that would be if let's say if n is less than 1. Because recall, we're calculating the product from 1 all the way up to n. So 1 is the smallest value that we can take. So if we say if n is less to, or rather if n is equal to 1, then we can just return 1. Because 1 multiplied, shouldn't even multiply by itself, but 1 by itself is 1. That's a tautology. If we want to be really careful, we can put in an error check. So this would even go before the first step. Error check, and that is if n is less than 1, return -1, meaning something went wrong because our method expects an input value greater or equal to 1. So that's the error check and the first step, meaning the base case. The second step is data shrinking. And what that means is the data that we get as an argument, so in this case n, how do we make it come closer to the base case? So how can we make n come closer to 1? And if you notice how I was counting this problem, we start off with n. We want to be able to, let's say if n is 10, we might want to do 10 times 9 times 8 times 7, all the way down to 1. So what we want to do is we want to decrement n essentially. We will be reducing n, so n starts at 1, eventually it'll get down, sorry, if n starts at 10 or some higher number, eventually it'll come down to 1. Instead of doing it this way, I'm going to create a new variable. Let's call this new n equals n minus 1, just because I want to preserve n for now. And then the third step is the actual recursion. That is where we call our actual the method over again. Factorial and new n. Now I could have also done n minus 1. They both do the same thing. But let's just be fancy and do this. Now consider example what we're talking about. So let's say if n is originally 10, and the factorial method is supposed to return the result or the product of 10 times 9 times 8 all the way up to all the way down to 1, then factorial of new n is supposed to return the product 9 times 8 times 7 all the way down to 1. So we assume at this point, we assume that the method works perfectly. We assume that when we call this method, it's going to give us the result of 9 factorial. So if we have 9 factorial, how do we get 10 factorial? Because that's our product, or that's the result that we want. And simply, that would be n multiplied by 9 factorial. So, let's see, and that is essentially what we want to return. Okay, so let's try this out. We'll create a main method. Factorial of 10, and let's just print that. And it seems like we have a typo here, and we're missing a close parentheses. And let's see, what am I missing? Oh, I just need this to be a static method so that I can call it directly like this. So if we run this, is this the correct number? We should have some way to verify it, which again we can easily do using a for loop. I equals 1, I less than or equal to 10. So this is just a way to verify that our result is correct. And we can just print the value here. So if we run this again, we get, we calculated the factorial value correctly. We can always try different numbers. So let's say Just try 5. And this also comes out correctly. And let's say if you try 1 itself, let me just keep updating this. Well, 1 factorial is just 1. And now if we try some kind of error case, let's say -5, hopefully this gives us -1. And that's because we put in error checking right up here. So once again, recursion has 3 steps. That's the best way to think of it. The first one is the base case. This is where you don't want to recurse anymore. This is the smallest input you can take, which is, in our case, n is equal to 1. The factorial of 1 is just 1. That's straightforward. The second step is data shrinking. That is the input that you get. In this case, the n, we want to bring it closer to 1. So we decrement it by 1 because we need every single digit between n and 1. So we decrement it by 1. And then the third step is using the actual recursion. So you call the method again with our shrunk value. And then you actually use it like this to actually get the final result. So here, this would have gotten us 9 factorial when our initial argument was 10. And then 9 factorial times 10 is actually 10 factorial. So this was a very straightforward example. This is a very common example that people use for coming up with recursion. Do we have any questions, comments before we move on to some of the more complex examples? Does a recursive method compute quicker than an iterative method? That is a great question. And a lot of time it depends on the language you're using and what the actual method is doing. For this particular example, I would say that the for loop is a lot more quicker than the recursive version, because the method body or the for loop body is quite straightforward. We just have just a multiplication taking place. However, in the recursive version, we have all these extra steps, and we also have extra method calls. So in this particular version, this is the recursive method is going to take a longer time. However, these problems are small enough that to a person, these differences are not noticeable. So if we just click play, they come in. Let's say even if I put it in for 100, and let's see, if I pull it in for 100, it should be very straightforward. What did I do? That shouldn't be 0. Oh, I think it's just because the value itself is too big. That's why I can't compute. Does 20 work? And we play it again. So 20 factorial is so big that it runs into a number overflow issue. But you can see it still happens in the blink of an eye, and there's not much of a difference between the two. So that's why it's straightforward. When you actually come to the bigger problems, the problem that I was mentioning earlier, that's when the for loop or the while loop becomes a lot more complex, which not only is a lot more difficult to think of, but it does perform slower. So it's a very problem by problem basis type of answer. Unfortunately, there's no one answer which says one is better than the other. A case by case basis. Is it better to write the data shrinking on a different line rather than factorial n-1? So this comes into a sort of a personal preference, but also, again, a case-by-case basis. In this particular example, the data shrinking is very straightforward. It's just decrementing by 1. So, personally, I have no issues doing this. But in some cases, the data shrinking is not as straightforward as this. I think we might see this in even in the second example, we'll see that the data shrinking is not as easy as this. Therefore, it's necessary to do it on a separately as compared to just within here. So again, if it's straightforward, if it's something very simple like n-1, feel free to do it within the feel free to do it like this within the method call. But if it's something more complex, as we'll see in the next example, you would want to do it separately like this. And speaking of the next example, let's move on, unless we do have other questions. All right, just going to put this over multi-line. And hopefully you can still see the whole screen and nothing is being cut off on here. And so the second method asks, given an array list of alphanumeric characters, return the string that concatenates these characters in reverse order. So for example, if the input list is A, B, and C, then the result should be C, B, A. And once again, it's very easy to imagine using a for loop or a while loop for this, but we want to use recursion. So we'll start off with the method signature, and the return type should be a string, and just gonna call this reverse. Okay, so our three steps again. First is base case. Second is data shrinking. And third is recursion. So, just to be safe, we can add a 0th step being the error checking. So in this case, the error checking might be if the list is null, you just say return error. Or if you really want to connect this to the previous coding challenge, we can have an IO exception. An IO exception, it's a null pointer exception actually. If our list is null, we throw a null pointer exception. Now the base case, what should be the base case in this for this problem? So we have a list. It's supposed to contain a bunch of characters, and we're going through one character at a time in this list and doing in a recursive manner. So what would be the situation where we don't recurse anymore? Does anyone have a suggestion? Please let me know in chat. This also gives me a break to take a sip of my tea. All right, list contains one element. Perfect. The list contains one element, then we don't need to recurse anymore because, a reverse of one element is just that element itself. So we can do this easily. If list dot size is 1, return, let's see. So essentially we want to convert the character into a string. So we can easily do this way to convert a character into a string. So we have our base case completed. Our data shrinking. So this is where it comes in handy to to do data shrinking separately, what we're going to do is we're going to contain a string, or rather the array. So let's say if our list is A, B, and C, we want to create a list with just B and C. So not B and C, sorry, A and B, because we want to concatenate the string in reverse order. Keep that in mind. The reverse order is very important. So we're taking away the very last element. And for that, we can create a new array list. New list equals new and we can actually populate it. I equals 0, I less than list.size, I plus plus. And actually what we want to do is I less than size minus 1, because we are getting rid of the very last element. So and then what we do is new list dot add list.get I. So if our original list is A, B, and C, we want to get A and we want to get B. That's it. We want to take the C out of our recursion. And now a third step is we do recursion. So what was our method called? It was called reverse on our new list. Now notice it's very difficult to do all this in here. I'm sure there are different methods you can call on the array list, but you want a very straightforward, non-complex solution. If we go with this kind of strategy, difficult to do it just within a pair of parentheses. Okay. So this is supposed to, if our new list is equal to A and B, this is supposed to return BA. Because once again, recall, we assume that the method works properly at this point. So if this works properly, it's going to get this list AB, and it's going to return as a string BA. And our original character here was the C, so we can just add on the C here, meaning we can get list.get or then list.size minus 2. Now what this is essentially doing is getting the very last character, because list.size would return, so we do need list.size minus 1, because that would return the very last character in our from our array list. And we just return this. So let's try this out again. I'm going to comment out these lines because we don't need them, or rather, and pass in a list. Now we can actually create the list up here. So let's go all the way up to F here. And now if we try it, the return should be FE, B, C, B, A in reverse order, which works as expected. as we wanted to see. You know, we can actually change stuff around. We can actually add numbers in here. Not at all. And that should not make a difference. There should be FE3D and the same. Yep, FE3D TBA. So we get this a string from contents of this list, but in reverse order. I may not be focusing on this, but how efficient would it be given a very large list? There are a lot of iterations over the collection given the for loop. Okay, so how efficient would this be? That is a great question, Graybeard. So yes, if this list is quite long, you know, let's say even thousands of characters, or you know, let's go crazy, hundreds of thousands of characters, this loop is going to take a long time, and at the same time, we're going to be calling this loop, you know, hundreds of thousands of times based on however many characters there are in this list. So this would become inefficient really fast. And in at a later example, we'll see how we can make this kind of recursion a bit more efficient, so that we are not necessarily doing this every single time. But we'll come back to that example a bit later. Again, great question. Yeah, so this would get inefficient very fast if we have a very large list. But once again, recall what I said earlier. These toy examples are there for you to get familiar with way of thinking for recursion. These examples, it may be easier, maybe more efficient to use them to solve them through a for loop or a while loop or something like that. But the point is to get comfortable with recursion. And if you want to, you can come up with a different solution, like a while loop or a for loop, to verify your answer, like we did down here. But are we allowed to use for loops in the coding challenge? In the next coding challenge, I'm not 100% sure, but I don't think so. I think the JUnit testing tests your code if you have like a for loop or a while loop in there. The solutions are supposed to be recursive. How will we do this without a for loop as long as we're not allowed to use? Coffee Pizza, how would we do what without a for loop? The reverse example? Well, if you're not allowed to use this in the for loop. Okay, so we can actually come back to that. We will actually come back to how to do this solution. Or you know what, let's do this right now. I was planning on coming back to it, but we can actually create a different version of reverse that can do this without the for loop. So I'm going to call this public string new reverse, and it's going to take in the array list of characters. And we are going to use a helper method to make our lives a lot easier. So what we're going to do is let's see, return reverse helper, in which we pass in the list, and we pass in list.size. Actually, I'm just going to do the error checking in here. So we're going to create a different method called a reverse helper, which is actually going to do the recursion in itself. So that would be public static string and cursor, and I forgot to make this static. So here we have the list as is originally, but we have an additional value being the cursor, and this tells us where we are in the list. So since we are starting at the very end of the list, this would be list.size -1. And here our base case is going to be if the cursor is 0, meaning if we've reached the very beginning of the list, return list.get 0. Here, when we do information shrinking or data shrinking, we want the cursor to come closer to 0 because it starts off at the very end of the list, however big the size of that list is, and we're essentially going down from there. So we have here, we have cursor minus, or let's do the same thing we had earlier. New cursor equals cursor -1. And the third step being the recursion, we do reverse helper. The list stays the same. We use the new cursor, and then we concatenate that with oh, sorry, forgot to make this into a string as compared to character. So this is yet a different way of thinking about this problem. We're doing the same thing. Given an array list of alphanumeric characters, return the string that concatenates the characters in reverse order. For example, if we have the input list A, B, and C, then the result should be the string CBA. And we start off with this method. At first we just check, is the list null? If it is, we just throw a null pointer exception. This is error checking. But then instead of having this new reverse method recurse on its own, we actually create a helper method where we pass in additional data, which is essentially a cursor within the list. So the cursor, so let's say if our list was, again, A, B, C, let's just go with A, B, C, and E. Initially, the cursor would be pointing at, let's 3, because this is index 0, 1, 2, 3. So this is, the cursor is telling us which character or which element in the list we are looking at. That's why we start off at cursor equals the size of the list -1. And each time we move the cursor back once. So we started off with 3, now we will move back to the C, so cursor equals 2, cursor equals 1, and at the very end, it means it means that the list is empty, so the cursor should be at 0. So if you try this again with the regular reverse and new reverse, it works the same way. With these new methods, what would happen if they passed in an empty list? Great question. So let's try it. I'm going to comment out all the adds to the list, and I think what's going to happen, it's going to be an exception thrown. And here we go. And it's an array index out of bounds exception. And this is because when we get here, our size of the array is 0, So when we try to do list.get 0, it should it tells us that there's nothing to get because the list is empty. Or more like actually when we try to do here list.get cursor, that here recursion reverse helper. Yeah, so when we try to get here, because this at first we would get list.get 0, and then we would do recursion, and then the cursor would be a -1. So in order to do this, we can actually fix a base case, and that would be if list.size is 0, then return an empty string. Yep, great. That's exactly it. On line 70, we try to get the point at -1 because list.size is 0, and then we subtract 1 up here. Not up here, sorry, up here. When we call reverse helper from the very first time, because list.size, sorry, here cursor is not 0, it's -1, so this if statement is not going to hold. It's going to come down here, and it's trying to get the cursor at -1, which causes our out of bounds exception. But it's an easy fix from here because we can say if the list is empty, then return the empty string. And actually, this would be a similar problem in our original case. So if we do instead of new reverse, we just do the original reverse and run that. Does the same thing, but at line 47. Because again, it tries to get list.size is 0. -1 is going to be -1. So in order to fix this again, we just update our base case, prevent that from happening. And once again, an empty list could be a valid case, or it could be an error case. Our method description here does not say anything about handling empty cases. So for this kind of situation, I would recommend taking a look at the test cases. So if you actually try running the program or running the test cases, and you're not passing all these test cases, then you probably need to consider the empty list, which we ignored at the very beginning. But yeah, that was a great catch. Thank you. And if we add him back, it should be working fine properly. So we have the regular reverse and the new reverse. So both of these methods work properly. And I should mention, if you're doing formal testing, you probably need to have JUnit tests as compared to doing some manual tests in a main method. This is not formal testing. This is just for the purpose of making sure that it works informally. All right. Any other questions or comments about the reverse example before we move on to the next one, which is palindromes? Okay, I don't seem to see any questions or comments. All right, so do we know what a palindrome is? Or is that a wrong spelling? Is it palindrome? I thought that was the right word. I gotta look this up, otherwise it's going to bother me. I know it's palindrome. think I have the right spelling here. So palindromes are words that are the same forwards and backwards. So if we want to look at some example palindromes, noon is a palindrome, coffee pizza. That is true. Or instead of actually me looking it up, I'll give this task to you while I work on the solution. We can find some funny palindromes. We can use those here. So I'll just start off at my my method signature again. So this is supposed to return a Boolean. Is palindrome, and this is our word. So let's do some testing or some just thinking how we are going to solve this problem using the word noon. We check the end elements of the list, comparing them and working inwards. Yes, that is a great way for checking palindromes. Here we would check the first n. So we would check the first n. Does it match? Does the first character match the very last character? If it does, so equals last star. If it does, then recurse by removing first and last char. Else return false. Because if, let's say, we had noon 5, the first character is not equal to the last character, so we don't need to check any further. So that's a great thing. Another way is, let's say if we have no 5 on, or if anyone can think of or send me a odd number of characters in a word or a statement, which is a palindrome. So that would be an interesting case as well. And then while you search for that, let's start off with the actual recursive. Madam and race car. Okay. Let's take race car for now. Okay, so we have, and we're checking this manually for now. So we have the first character and the last character are the same, so we get rid of them. The A and the A is the same. Again, the first and last. Get rid of them. The C's are the same, first and last. But now you should see we run into something that we hadn't seen before, and that is we have a character by itself. And we know that the word race car and the word even the word madam, they're both palindromes. But we have a character by itself, which should imply that a character by itself is a palindrome. So just the letter E is a palindrome. So, so with that in mind, let's try to work on our 3 steps. So again, base case, and then we have data shrinking, and then we have recursion. If it's a sentence, will you ignore white spaces, or will you will you ignore case? So the part about ignoring white spaces and ignoring uppercase and lowercase, that is very application dependent. We can make our example any way that we want. So I'll leave it up to you guys, guys and girls, to show or to make a statement, to make a judgment, to say should we ignore, should we make it case sensitive, or should we make it ignore white spaces, or should we consider them as well as part of the palindrome? I'll let you vote in chat, and then we can modify the solution if we need to. Okay, base case. Here, our base case would be if we either have an empty string, so that's something similar to what we saw earlier, an empty list or a list of size 0. So if you have an empty string, we know it's a palindrome. Oh, sorry, return true. But as we saw up here with the race car example, we know that a single character by itself is also a palindrome. So if the length is 1, it's also a palindrome. We don't need to recurse anymore. And now we want to do information shrinking. So we want to remove the very first and last characters. And the way we do that, we're going to create a new word. And then we want to get a substring. I just want to make sure we have the correct method for doing so. So here comes in handy the Java API. Was it a car or a cat I saw? So we can actually try that one when we have the solution ready. And there should be a method called substring. There we go, the beginning index and the last index. Hamburger, so and then 0, 1, 2, 3, 4, 5. Okay. So that would be word.substring. So we want to ignore the very first character, and we want to ignore the very last character. That would be word.length minus 1, I believe. And before we actually move forward, we can actually try it out. So I'm just going to say return true for now. Let's say if we have the string hello, we want to print s.substring starting at 1 and ending it s.length minus 1. So if it works right, it should ELL should be the result here, which is what we see. So that's good. We know how to get the substring where we remove the very first and last characters. This would be our new word that we were going to recurse on and get rid of this line. And then we would do is palindrome for our new word. Now notice, unlike the previous solutions, we can't just add this to our recursive result. Before, when we were working with factorials, we would just multiplying things together because we wanted to have like 10 times the 9 factorial and so on. Here we're concatenating strings, so that's why we add them together. And that still works. But in this case, in the is palindrome case, we're working with booleans, so we can't really add things together. And if you recall our check here, if the first and the last character are the same, we move on. Meaning we get rid of the first and last character and then we recurse. However, if they're not the same, then we just return false. We no longer need to recurse. So we can add this check here. So we can say if word.charat 0 is not equal to word.charat, then would be word.length minus 1. Return false. Otherwise, do the recursion, and this recursion is either going to return true or false. We just want to return whatever the recursion returns. Okay, so let's start off with another example. So we have this from the dot.println. So we want to try the words noon. And we had race car, madam. Or actually, what I'm going to do is so that we actually know what the output statements are talking about. So we had race car, lowercase n. We had madam, and then we had was it a car or a cat I saw. All right, so let's, if we run them, so we say noon is a palindrome. That's true. Is race car a palindrome? That's true too. So is madam. This is what we expected with these words. But here we have a lot of white spaces, which do not make it consistent. So example, like the word was and saw. Sorry, the word was and saw may be similar, but at the same time, the W and W are lowercase and uppercase, so that our problem here is no longer considering this a palindrome, because our solution is case sensitive when we do it this way. To fix this issue, we can just do word equals word dot to lowercase. So we can just convert everything to lowercase so that we ignore case sensitivity. But this still says it's not a palindrome because, again, the word I and it, so it expects a space after I, but it's not there. So that's why it's not a palindrome. We can further modify our solution to actually ignore white spaces. So the way we would do this is, let's see, so we want to get the first character. So that would be yeah, let's see, how would we get the first character? So first character is going to be word.char at 0, and then while the first character is a space, we have a counter starting at 0, or rather counter starting at word, and also should be cat. Is a cat palindrome? Because T and A are not the same character. Or did I miss something? Was it a car or a cat? Okay, I see. Was it a car or a cat I saw? Okay. I'm going to comment these out for now. It's still false, also still because you know, the IT versus the I space. So that's the reason why it's considering issue. But thank you for pointing out the typo. But what we're trying to do is getting rid of white spaces. So what we want to say is, while the first character is a white space, we want to say first is equal to word.char at count, and keep incrementing count. And then same thing for the last character. That would be word.length -1. You also do a word.trim. That is actually that is possibly a better idea even than what I was trying to do. So you trim the word and then you get the character at the very beginning. Or I don't even need that. I can just do this down here. So if we were to do it this way, oops, we ran into some issue. String index out of bounds, range 20. Let's see. So this is here, and that might be because, let's see. Just do word equals word.trim. What am I missing here? Usually something small. Essentially what I want to do is if there's a space at the very beginning, I want to get rid of that. And if there's a space at the very end, I want to get rid of that as well, but those are independent. Length is, that is true. That is a great catch. Thank you for all your help tonight, Graybeard. Really helpful. So if we do word.trim here as well, that should fix the issue. However, it's still saying that the thing is false. So what we can do is we can actually try to figure out as to why this is saying it's false. So we can actually try to print the word. Okay, did I make another mistake? Was it a car? A car or a cat I saw? Okay, there's probably just something smaller in this. We can come back to it. I just want to save some time and actually move on to the next one, because I think we still have one more to go, and then we can come back to this one. My apologies, I'm just missing something here. Now it's going to bother me for some reason. It's going to keep bothering me. Okay, we'll come back to this one. Let's actually talk about the very last one, which is the Fibonacci sequence. Is given an integer and compute the nth Fibonacci number. So if we recall, or do we know what the Fibonacci sequence is, or should I just briefly go over the concept? Okay, I will just go over the concepts, what it is. So Fibonacci sequence is a sequence of numbers that start off with 0, 1, 1, or rather sometimes they just say start off at 0 and 1, and each next number is the sum of the previous two numbers. So 0 plus 1 is 1. The next number is going to be 1 plus 1, which is 2. The next number is going to be 3 because 2 plus 1, and then 5 because 2 plus 3, and then 3 plus 5 equals 8. 8 plus 5 equals 13, and so on. If you actually look it up, if you look up online, this allows for some very interesting patterns in nature even. So this is a very interesting sequence. So when we're working with recursion, again, our same 3 steps: the base case, data shrinkage, and recursion. Here, the base case are the very first 2 numbers of the Fibonacci sequence. Because recall, every subsequent numbers is the sum of the previous 2 numbers. So either the very first number or the second number cannot be calculated this way, because when we try to compute this 1, it would be 0 plus something, which doesn't exist. So these first 2 numbers are hard-coded. So if we say if n is 0, or rather, we say if this is the 0th number, because computer scientists, we start counting at 0. If it's the very first number, meaning if n is equal to 0, then just return 0. Else if n is equal to 1, so if n is here, the second number, but n being 1, then return 1. And here we actually need to we can actually do data shrinking again. Okay, so here would be int. So we know that n is a positive number, and it has to be greater than 1, because we've already taken care of 0 and 1 here. And if you were to do an error case, if n is less than 0, then just return -1. So we know that n is necessarily a positive number. It is either 2 or greater. So the first number is going to be n minus 2. And the second number is going to be n minus 1. So once again, if you're computing this 5 here, we would take the nth number minus 2, which is the 2 here, and then the nth number minus 1, which is the 3 here. So 2 plus 3 is equal to 5. And interestingly enough, here, since we need the 2 previous values, we need to recurse twice, not just once. So what we would do is here is Fibonacci first plus Fibonacci second. And we just return this. Because once again, if you're trying to compute, let's say this 8 now, if we have n equals 0, 1, 2, 3, 4, 5, 6. So n is equal to 6, which means we need the Fibonacci number 4, the 3 here, and the one after that, and the 5th. So 3 plus 5 being 8. So that's why we have n minus 1, or sorry, n minus 2 and n minus 1. And when we sum these 2 Fibonacci numbers together, we get the current Fibonacci number. Okay, so let's try this for now. I'm going to comment these out. Fibonacci, let's say the 5th Fibonacci number. We run this, we get 5. So let's just try this again. So 0, 1, 2, 3, 4, 5. Straightforward. So let's try 6, 7, and 8. The 8th number, we expect it to be 21 unless my math is wrong. It's not, luckily. So if you were to try to, let's say, the 9th number, so that should be 21 plus 13, which is 34. That works out. Similar to the second example that we saw, this recursive problem is going to run into efficiency problems if the number we put here is quite big. Let's say if we were to put in a 100th Fibonacci number, it might take longer than we expect. So we can see it's running. You can see the circle on my, or the loading symbol is gone. However, the method is still running, and because this red button is on and there's nothing being printed. And that's because it's calling the same values over and over again. Because in order to calculate this 21, we need to calculate the 13 and 8. But in order to calculate the 13, we need to calculate the 5 and 8. So the 8 is being calculated twice. Similarly, when we need to calculate the 8, we need the 3 and the 5. When we need to calculate the 5, we need the 2 and the 3. And so it keeps on adding, and it blows up exponentially however many times we're trying to call this number. So instead of doing it this way, we can have a workaround to make our lives easier and make this calculation a lot faster. But the idea is going to remain the same. And once again, we're going to use a helper method. So public static int new Fibonacci. And then we're going to put our error case here. Then we're going to return fib helper. Java is so confusing coming from a JavaScript background. So Java and JavaScript are very different languages. Just because the name sounds similar, it should not be considered that they're both the same thing. There's car and carpet. The names sound similar, but we all know that those are two different things. It is a bit similar in syntax, but the way of thinking of this language is, and how classes work in Java, I don't even think there are JavaScript classes. It's been a while since I did JavaScript, but it's the way of thinking for it is completely different. So when you think Java and JavaScript, think car and carpet. They may sound alike, but they're completely different. JavaScript does have classes. Okay. Coming back to the Fibonacci helper, we're going to have the n passing in as normal, but instead of counting down, so notice here we were always counting down from n all the way down to 0, or rather n all the way down to 0 or 1, we'll count up. We'll count up, and we'll actually give it the very first two Fibonacci numbers. This is how we get started. So we have 4 values. The first value here is our target. That's the cursor, or that's the Fibonacci number that we're trying to calculate. This is the Fibonacci number that we are starting off with, which shouldn't be 0 or 1, should actually be 2, because we've actually created 0 and 1 here. So we can actually do some extra helping. So if n is 0, we can return 0. Else if n is 1, return 1. So we create some special cases that we can handle manually. And since there's only 2 of them, it's okay to do so. But if there were like 100 of these special cases, then they're not so special because there's too many of them. But since it's 2, we can handle the first 2 special cases. But now when we call fib helper, it expects that the starting number is always greater than or equal to 2. So we can do public static int fib helper, so that would be our target. This is our current position, int first, int second. By first and second, I mean these two values right here that we calculated, the Fibonacci of n minus 1, sorry, Fibonacci of n minus 2 and Fibonacci of n minus 1. So that's why I call them first and second. Recursive chat. Interesting name for this stream. Okay, getting back here. So in here, our base case is going to be if our current position is our target. So let's say if we are trying to compute the 10th Fibonacci number and we are already at number 10, then we don't need to go any farther. So we can just return the sum of first and second. Now, information shrinkage, or rather the data shrink, and that is we are trying to get current closer to the target. So the counter is very important. Previously, we were counting down from n all the way down to 0 and 1. Now we are counting up from 2, or rather from current, all the way up to target. So that would be int next equals current plus 1. Because again, we're counting up, so we add 1 this time. And finally, the third step, recurse, which would be, let's see, okay, which would be returning the fib helper. Our target does not change because that's going to be used for our final result. The current value does change because we updated it by 1, so that's next. And this is where the interesting stuff happened. Notice this this first and second. So I'll pick up the example from up here. I'm going to just copy this down here. So initially, we have 0 and 1, 0 being the first, 1 being the second, as passed in here. When we are computing the third Fibonacci number, it would be 0 plus 1, so that's 2. And now when we consider the next Fibonacci number, is going to be 1 and 2, which is 3. So notice that the numbers here were, we went from 1 here going from the second to the first here. Right, so when we do 0 and 1 for our third Fibonacci number, the 0 comes first, the 1 comes second. But when we're computing the fourth Fibonacci number, the 1 comes first, and the 2 is supposedly a new calculation, which is first plus second. Did that make sense? Should I go over it again? This is where the trick happens in this form for this exercise. We have the values first and second, but when we recurse, our second comes in as the first for our recursion, and our actual second is a sum of first and second. So I can actually try, instead of just saying Fibonacci, new Fibonacci, and if we run this, again, it runs into some kind of number overflow issues, but you can see it calculated it really fast, whereas the previous version took a long time to and it didn't even finish. We had to stop it manually. Let's try something a bit more simpler. Fibonacci number 50. Again, these numbers grow so fast, so that's why we're running into a number overflow. But if you can actually try to fix it using a long instead. If we were to do, let's see, convert all these integers to longs, and hopefully that might help us compute some of the bigger numbers. There we go. So we can at least compute the 50th or the 51st Fibonacci number, which is big. This big thing down here. Can we go up to the 100th? We can. Wow. But that's a very big number right here. So once again, the original Fibonacci sequence, we counted down from n all the way down to 0 and 1. And then we just kept summing up the two previous Fibonacci numbers. But as we saw, as n grew higher, this method became a lot less efficient. So when we had like Fibonacci of 100, it ran for a very long time and we had to stop it manually. I'm not sure how long it's actually going to run. But we change our thinking a bit. We create a helper function. So we start off with a new Fibonacci, where notice that the input for n stays the same. And the way we call it down here in our main method, we didn't change anything here except for the method name. The input remained the same. But the way we use that input and passing towards the helper method is where things come in hand. It's where the trick happens. We do our error handling in special cases. So if n is less than 0, that's error handling. But if n is either the first two numbers, we can just return them using using hard coding the results because they're straightforward. But if it's anything greater than the second number, so a third or higher, we use the helper function. We specify what our target is. This was n from our initial call. Our starting point is 2. So the current cursor is at 2 because we're looking at this Fibonacci number that we're calculating. And then we give it the two previous Fibonacci numbers. So if we're calculating 2 here, we give it the 0 and 1. So our base case in the actual recursion is, has the current cursor reached the target? If it has, we just sum these two numbers together, and that's our nth Fibonacci number. If it hasn't reached it yet, we update current by 1 because we wanted to get closer to the target. So the range between current and target. So so I would say since target is greater than current, so target minus current is greater than target minus next. So this number is getting smaller, hence the shrinking. So we do data shrinking, and then we do the recursion where our target remains the same as before. Our cursor has moved up by 1, so that's next equals current plus 1. And our second number that was passed in here, so initially the 1, is passed in as the first value, while the second value is newly calculated by taking the sum of first and second. Hopefully that made sense. If not, if you have any questions, comments, please let me know. I'll wait a few seconds for you to... I know there's a delay between me talking and what you're actually seeing on screen. I'll wait a few seconds for questions and comments. Otherwise, we can move towards the end of the tutorial. So I should mention, I am going to come back this palindrome issue and considering why we can't figure out this particular case. But for those who don't want to stick around to find a solution for this, I'll just do my conclusion for now. And that is, so once again, this recording will be updated on the YouTube channel probably later tonight. There is a link to the survey in the description of the channel. Please fill it out. Because that information will help me to do more sessions. This is the last session for this semester, but you know, there's always next year, possibly other courses. So this information is really helpful. If you've attended this, well, you know, if you found this session helpful, and if you attended some of the previous sessions and you found them helpful as well, please let the course instructors know. Maybe let the department know. You know, send an email to the department head. Let them know that you found these sessions really helpful, so that in the future we can host more of these sessions. So that I'm not the only one. There are other TAs that are able to do it. Probably even people who are better than me at this kind of stuff. So that, you know, we can have better tutorials suited for the students. There is new technology available, so you know, might as well make use of this. So we have that. And then once again, we're getting near the end of the semester, about a week left. Thank you all for attending these sessions. Hope you had a great end of semester. Good luck on your final exams. Good luck finishing your project. And yeah, thank you for a great semester. Now, for those who want to stick around to fix the palindrome issue, let's get back to it. I'm going to comment out the first three. Okay, let's try this again. It's saying it stops here at a cat, car, or a cat. Why is that? That rhymes. It's been a long day. I know I'm laughing at silly jokes. Okay, so we have word.length and word.length minus 1. So instead of doing this, I'm going to be computing the new word, or rather printing the new word. Okay, so the W and A are good. The S is good. The I is good. And the T's are good. Now that is so it goes down here, and it doesn't see this. So how about if I trim this right away? Keep printing it. There we go. It was a simple trimming issue. And I think we can get rid of the trims here. Was it a cat? Was it a car or a cat I saw? It is a palindrome. True. So the solution was easier than I had anticipated. Anytime I create the new word, so I took away the end characters, I just need to make sure I take away the extra spaces too, just to make life easier. I do it here instead of down here, because I think we had to do something a bit more. We were taking them down here, but we take out those characters, we trim them, meaning we get rid of the trailing white spaces, and our solution works. So now this solution is not case sensitive, and it does ignore white spaces. If we don't want to ignore white spaces, we get rid of this dot trim. If we don't want to be case sensitive, we get rid of this word equals. And you would notice that this particular line is being called over and over again. We may not need to. We only need to do this once because the original word we get is as soon as we convert it to lowercase, anytime we recurse with the new word, it's going to be lowercase. So we can always make this into a helper. And then palindrome. Then we can also do error checking if the word is null. Then just return false, or you could throw a null pointer exception. Otherwise, you can do is palindrome helper word.to lowercase, and then we can get rid of this line down here. We run this, and if we did this, we want to return this as well. We've done this properly. So this using the helper method allows us to convert it to lowercase only once, so we don't have to do it over and over again in our recursive calls. All right, so we figured it out. That's awesome. Thank you for all your help, especially Graybeard, for all your great comments and questions. Do we have any other questions and comments before we call it an evening? All right, I'll take that as a no. Once again, thank you all for attending, and thank you for sticking around to figuring out the final solution. No, thank you. I learned something tonight. You learned that you don't like recursion. If you want to stick around in computer science, programming, recursion is a great tool. It's very helpful because it's a different way of solving problems. You might hear this often, that's computer science or computer programming. An important part of it is being able to solve problems, meaning you're given a situation and you have to figure out how to actually come up with a solution. Being able to think about the solution in multiple ways can be really helpful in the long term. Because if you're given the more complex problems, which again I didn't mention here because we're considering an introduction to recursion here, if you're given those complex problems, the solution using for loops or while loops or any other kind of iterative solution are a lot more complex than recursive solutions. So for those of you moving on into Computer Science 331 next year, you might see things like binary search trees, linked lists, stacks, priority lists, and so forth. And that's where recursion comes in really handy. It would be a lot easier for you to come up with solutions using recursion as compared to using a while loop. And once again, it'll be much more efficient when you use recursion in certain concepts. But I understand it's a completely different way of thinking. It doesn't click with everyone right away, but the more you practice, the easier it'll get in the future. All right. If there are no other final words, awesome. Thank you for these sessions. You're welcome, Coffee Pizza. I enjoyed doing these sessions myself. I just like teaching, so that's why I asked the instructors if they were okay with me doing these sessions. They said they were, so here I am. I should have started earlier in the semester, so I think we could have gotten a lot more sessions then. But I'll keep that in mind for future courses. Okay, so one final outro for the semester. My name is Zan Rizvi. Thank you all for attending, and have yourself a great evening.